server about the weird behavior I was getting.
Was this the
On my
locale
on my
business?
MacBook. Huh?
Was this the business with the localization?
Yeah.
Yeah, because you had
Um,
this in 224, right?
I had a similar problem in 224. That had something to do with SSH sharing locale information, and it was messing up the how the sort command worked
Mm-hmm.
somehow. But I disabled that in my SSH RC file or whatever it's called. I can't remember. I
Okay.
disabled it, and that fixed the problem in 224. I was reading a similar problem again. And I was thinking it's very strange that it would be the locale because I'm pretty sure I disabled that. And when I tested using like scanner.locale, testing that locale scanner was running in, it said English US, so that seemed right.
Mm-hmm.
Um, so I don't know what could be going on there that would cause no pointer exceptions from running in different SSH clients. It's
Mm-hmm.
very, very weird.
It is very weird, and I don't have an explanation. Um, I didn't have a really great explanation in 224 when this was going on. And it's not something I can reproduce because I don't have a Mac. Um, but I mean, my suggestion would be if you're going to keep running from a Mac, make sure the code works on your Mac, and then you just kind of have to hold your breath and have faith. I think that it's going to work on the server, and that's kind of a risky proposition. I think it's probably, if you're very careful, that should be fine. Um, but um, but that's a problem. Um, and I don't know why it's only happening on Mac. Um, but that seems like something specific to Mac as opposed to Java. Um, if you, I'm not sure. Yeah, you could try a VM, as someone just suggested. You could try running Dropbox on your Mac, and once you've got your code working, download the file from the server, make sure all of that's working on your system, and then copy everything over to a Dropbox instance. And I don't know. I mean, SSH should be working fine also, so I can't say Dropbox should be working because it kind of depends how much the underlying system wants to kind of get its fingers into what's going on. Which is why, Windows will break Dropbox in so many different scenarios. It'll turn off this or change that setting and so on. But that would be a good thing to try. Um, do Dropbox on your OS and see if you can get it to work in that.
Well, hopefully it shouldn't be an issue for much longer. I'm looking to. Uh, Already, I'm testing and submitting my code on my Windows desktop.
Mm-hmm.
Works there fine. Hopefully, I should be getting a Windows-based laptop soon, so it shouldn't be an issue in the future. But that
Okay.
was something that threw me for a loop, and I was like, why am I suddenly getting errors when I didn't before? And
Yeah,
when I
it's
tested your code, I was also getting errors, and it was just such a strange experience that this is happening at all.
it is, and for people who didn't pick this up in Discord, now we're in 224. This was a situation where SSHing from a Mac and SSHing from a non-Mac were giving different results in the way the code ran on the server. And it wasn't running on the native machine. It was running on the server that you were SSH'd into. But OS X apparently, when you run an SSH client, it does some translation of some characters based on localization information. And something in the way that was happening was causing code to either succeed or fail on the Linux server, which is really bizarre. And when I heard you talk about this in fall, my first reaction was the same as everybody else's, which was just like, there's no way that's happening. But it actually was. And you can Google around and find various explanations slash theories for what's going on there. But yeah, it's pretty bizarre. And probably pretty annoying to try to work with. But yeah, since you have a Windows system, just do kind of like an acid test on there, SSH in. And I was going to suggest, maybe SSHing from the Linux server back to the Linux server. And that may work, or it may just transfer the localization information if you do that. But that would be one attempt from the Linux server. Just SSH username at localhost and see if it manages to forget.
I'll try that, see what happens.
Yeah, it would be interesting. All right, cool. Other questions, comments? So I got stuff graded that was submitted through yesterday. Submissions from today or tomorrow I'll get to in the next couple of days.
I don't know why, but PS3 was so difficult for me. I don't know.
Was so what?
Difficult. Like.
Yeah. I mean, I can think of a number of reasons. One being that it did not have as much instruction to it, right? So this was largely an exercise in thinking about how to set up classes and where to put different pieces of the machinery and how to tie them together. And that's probably one of the most challenging aspects of object-oriented programming languages is, with C, we don't really have any choice. You just write a bunch of functions and you call them. With Java, we've got a much kind of richer palette to work from. And it's not just breaking it into pieces, but it's, choosing which pieces go with which, and then how we share information between those. And PA4 is going to push that, much further, because the amount of interconnection between the different classes is going to be much greater, and is going to have a much bigger impact on how the final code base looks and acts. So that's definitely an extra challenge beyond what we've done so far. And then, we were working with a data structure we were building ourselves, the decision tree, and so all the dynamic memory stuff is another component.
In that case, I'm definitely going to visit you tomorrow in office hours.
Awesome, cool.
Got a question?
Sure.
This is for PA4.
Okay.
And being another classmate from the CSE223A class, I think, which uses Thursdays, working on the PA4 yesterday, but we weren't sure about the algorithm of how to kind of have it where if the user flips between two lines, it would create or two dots, it would create a line.
Ah, okay. Yeah, we will do that today for sure.
Yeah, we don't have the algorithms in our head, and we were thinking about kind of if there's like a range method or something like that to capture within a certain pixel radius or something like that. Like dimensions.
Yeah, we can do it with a couple of if statements, see if you're within some bound. But we'll talk about pretty precisely how we can do that without too much heartache.
I do have another question about. Are we going to discuss about event handling? Like, if a user would do something, it would trigger a certain method?
Yeah, I mean, that's kind of what we were doing on Wednesday with, drawing in response to mouse motion. The mouse motion is the event. The action we wanted to take was to draw a rectangle at the XY coordinates of the mouse. And so in the mouse motion, we saved the XY position in memory, and then we said repaint, and that called the paint method, and the paint method looked at that location in memory, which we called last X, last Y, I think. and it picked those up to draw the rectangle. And we'll keep going through that today. We'll maybe redo that, but with a clear button or a color button or something like that, and see what's going on.
Yeah, I remember like when I was you know how you click on like the design box and it'll pop up like code for you.
Mm-hmm.
Yeah, I was kind of confused about the syntax reasons of what is actually happening. I was wondering if you can kind of show a little, kind of go more in depth about how do you actually call a event, or how do you represent an event, and so on.
Okay, yeah, let's do some of that, and then let's look at some of the calculations involved in finding out where the person clicked, corresponding to, you know, edges of boxes and so on. Let me briefly mention the midterm before we jump into that. And Canvas, I don't have a Canvas page up. Let me hop on to Canvas. So your midterm is Wednesday. No surprise there, hopefully. And so I just kind of threw a little blurb on the midterm page here, or not. Oh no, I sent an announcement. All right, so sent an announcement last night. So midterm details to keep in mind, right? So the midterm is for us, it's going to be Wednesday at 10 o'clock, right? So the regular class time. The regular time is 1 hour, so it's well, let me double check. Because I set this part up a while ago. So it's 1 hour, 10 o'clock to 11 o'clock. Your answers, this will be basically exactly the same as CSE222 was. So you'll download a PDF or look at a PDF on Canvas that will have the questions. You write up your answers by hand, upload them as a PDF. So the midterm will have an upload area, and it will also have a clickable link where you can see the exam. So that'll pop up at 10 o'clock on Wednesday. You might have to refresh Canvas right before. So look at the questions, write up your answers, turn them into a PDF, upload that to Canvas. If you have an extended time allowance, just take the extended time. Canvas does not understand extended time, but I do. So if you've got a time and a half allowance, you've got an hour and a half. Exam starts at 10, turn it in by 11:30. Canvas will say it's 30 minutes late, don't worry about it. Okay? Whatever your deadline is, make sure you upload by the deadline. If you turn it in late, it's 10 points per minute, according to Canvas. So turn it in, you know, like a minute before the deadline. You can upload multiple times, so you can be turning it in as you go. An easy way to do this is, you know, have a Word document or an OpenOffice document. Each time you make a new page, turn it in, you know, take a picture of it, paste it into your document, right? And then there's an export button, export the document as a PDF. That's the thing you upload, right? Figure this out ahead of time. If you haven't done this before, figure this out, you know, make sure you've got your folders open, you know where your file is going to be stored, so you're not browsing directory trees and so on and so forth, and make it as automatic as possible. You finish writing a page, take a picture like with your phone or your camera, whatever you're going to do, get it on your computer, drag and drop it into your document, hit the export button. There's your updated PDF file, drag that over to Canvas, right, to upload it. So get that part streamlined ahead of time. If you're not sure how to do that, come by office hours tomorrow. We can work through your setup, see some sample tools, and figure out what's going to make that work best for you. So practice ahead of time. And I'm going to say, do not discuss any aspects aspects of the exam with anyone until after 3 p.m. Thursday, right? So each section has its own exam, but potentially if you talk to people from the other section about your exam, you might give them an unfair advantage, right? All right, and then academic honesty. I'm not going to dwell on this, but you know, basically all the work has to be your own. You can't receive assistance from anyone. You can't give assistance to anyone. If somebody looks at your work, that is cheating. If you look at someone's work, that's cheating. If you talk to somebody and say, did you get question 3, is that really hard? And they say, no, it's pretty simple, that's cheating, right? It's closed book. You're allowed 6 double-sided pages of notes. You can make them handwritten, type, whatever you want. But that's it. No other resources, no web pages, no online documentation, no online Oracle, Java documentation, no audiobooks, text messaging, sample code, etc. Only what's in your note pages, right? But you can put anything into those note pages that you want. So if you can't remember how to construct a scanner, or you can't remember what the import statement for it is, jot that down in your notes. All right. And I shouldn't have to say this, but I'm going to say it in particular. This means you absolutely cannot type any of your code into any editor, IDE, or any other type of system. You cannot compile it, you cannot run it, you cannot test it. Okay, none of that is allowed. If you, yeah.
Can we use an abacus?
Is it electronic? I think an abacus would be a resource. So I'm going to say no abaci.
What would you need an abacus for? Is my question.
This was in existence.
Need an abacus. It's good to have one on hand.
Yeah.
What even is an abacus?
Chinese calculator.
Yeah. Add, subtract, multiply.
Hey, do you guys not have? Do you not keep an abacus on you at all times?
I've got mine right here. I don't know about you.
Cool. The only bummer about an
Keep
abacus
on my keychain.
is you can't use it on a roller coaster. But you can use a slide rule on a roller coaster. That's the main advantage.
That's actually really useful. I haven't thought about that.
Yeah. And you can swat flies if you're inclined. All right, so hopefully that's very straightforward. But every time I've done this, inevitably there's a few situations where someone says, well, I think better in VI, so I was just typing it into VI to think. So I'm just going to say, none of that, and hopefully it's clear. But if there's any doubt, just ask, right? You never get in trouble for asking. What?
Who said they think better in VI?
Well, I think better in VI. I mean, I do better typing code than writing it.
I guess that, but I don't know. I feel like for an exam, I mean, come don't cheat. I mean, what?
Yeah. So if you're in doubt, just go ahead and ask, right? I mean, you can shoot me a chat message and say, hey, all my pencils broke. Can I use an editor instead or something? You can always ask, right? And I'll just say, yes or no. So hopefully that's clear.
I snapped all my pencils in advance on accident.
Yeah.
I read it in Notepad.
All right. So I don't know what the exam looks like yet. I haven't written them. But you've done 222, you've done 224. So some programming questions, maybe some short answer conceptual questions. Hopefully no surprises. Hopefully, I don't give you like Python code or something like that, or read my mind and write some code to do what I'm thinking. So they should be questions that are very similar to what you've been doing for your programming assignments, your ODPs, what we've done in class, that kind of thing. So if you're trying to figure out how to prepare for this, I would say go over your programming assignments. That would be first and foremost. Go over the ODPs and try to understand the concepts, right? So if you wrote a decision tree for PA3, I could ask you to do a binary search tree, right? Similar process, The decision tree code won't necessarily help you with that, but if you understand the higher level concepts that made the decision tree work, right, you should be fine. Let's see, are we not allowed to reference code we wrote for previous assignments on the server during the quiz? If you want to reference previous code, put it in your 6 pages of notes. Right? You can absolutely not log into the server during the exam. But if there's something in there that's helpful to you, go ahead and put it into your notes. There's a great little Linux command called A2PS, which will let you pretty print documents, files, things like that, and you can do like a 4 up or a 6 up or a 16 up that would put multiple pages onto one page of output. And so you can do that and get a whole assignment onto half a page and get a good magnifying glass. I'll let you use magnifying glasses. That's an allowed resource. So you can shrink your code down like that. I am recording as far as I know, so thanks for the check.
What, like shrinking down to like font size 4 or something?
Yeah.
Well, I feel like that gives the advantage to people with printers with high print density.
Or those with good vision. See,
That's true.
an existential question.
Yeah. That's up there with the abacus. Alright. I don't anticipate that you need, 6 double-sided pages of notes for this. I'm not going to, hammer you with questions. What are the 5 different signatures for the such and such method in the, such and such obscure class we've never talked about? I'm going to ask you about, linked list and strings and scanners and print writers and stuff like that. So it should...
Something like print page 65 of the Oracle.
Yeah, exactly. What's the 7th word on this page of PA3's assignment, So it should be pretty low-hanging fruit. Plan to spend, an hour on it because you'll be writing some code. But the things you have to do in writing the code should be pretty similar to things you've done in writing other code this quarter.
And is it we have to memorize a lot of the methods inside the linked list class or something like that?
The methods that we've used so far should be sufficient. So if you don't remember, whether it's add or add first or add last, just jot it down on your note sheet.
Okay.
But I'm not going to suddenly come in and say, what does the DQ method of the linked list class do, right? But I might ask you to write some code that, adds something to the back of a linked list. So... All right, good enough?
Just to make sure.
Yeah.
Any questions or references to statics?
Yeah, I can ask you about statics. So, what is a static?
Wait, I'm scared now because it sounds like you weren't asked about statics before, but now you are.
Samuel, you son of a gun, you. Alright, if I get a missing point on this exam because of some stupid static question, I'm coming for you.
No,
You know where I live.
You don't know that.
I'm not going to add questions to the exam because people ask about questions here. But no, I mean, so you definitely need to use static when you say public static void main, right? And when you want to use something like you want the value of pi, we know that pi is available from the math class, and you access it by saying math.pi, right? That's an example of a static, right? That's a static property from the math class. As opposed to, if you say rectangle r, and then you say r.width. Well, this is an instance property, right? It's a field inside the rectangle class, but you access it using a particular instance of a rectangle. So, you know, R1 has a width, R2 has a width, which might be completely different from R1's width, right? That's the usual type of variable that we declare in a class, and we would just say, you know, integer width or float height or something like that. But if we want to be able to access something as part of the class itself, we just throw the word static in front. So inside the math class, there could be a static integer named pi, and it's equal to something, right? And that keyword static says, hey, I can use the name of the class followed by the name of the field. And then the same thing happens with methods. If I want to take the square root of a number, I can say math dot square root of 2. Well, I don't have an object of type math. I'm just saying, hey, inside the class itself, I want to use a method named square root. Well, this would be declared as public static double square root, etc. And that's all that static means, right? It means that you can access this method or this field by using the name of the class, instead of taking it off of a reference to the object. Yeah,
Question.
go ahead.
So the thing is that when I was making PA3, I really wished I would be able to put like the play game method inside of the public static void main, but it gave me like an error saying that I have to make it a static of some sort. But is it? And I looked it up. Is it actually true that that in Java you cannot have a method inside of a method, or you can't have like well, yeah, a method inside of a method. So like you can't have you have to make a static method in order to create like functions outside of well, not outside of it. It's all, I want it all be a main, but I have to make static methods.
Yeah, so main is a static method, and if you have a static method, and you try to call another method, that other method probably has to be static also, because a static method is running without a particular instance of the object. It's running as part of the class. But in reality, right, if you had moved the play game into the tree class, so you could say, you know, tree t equals new tree, and then you could say, you know, t dot play game, then it doesn't have to be static. In fact, it does not want to be static. It's going to be just a regular method.
It's kind of weird because I really want to organize the code the way I want it to be, but then I have like these errors that say you cannot.
Yeah, and that's a little bit of the kind of tension of object-oriented programming, is you kind of have to learn to do things a little bit differently to really work with objects the way that objects and classes are supposed to be used. But I think you'll find it pretty comfortable once you get on the other side of that transition. And you know, you're free to always, you know, use C and write things that way, or you know, use an object-oriented language and write things a different way. But yeah, it is a different mindset, a different feel to the approach. But you know, main is really the thing that runs when you first say Java, you know, whatever the name of the main class is. And if you just want to play the game, yeah, maybe it seems like it makes sense to put that inside main. But if you're thinking about classes, right, what if you wanted to play, you know, 3 different games with 3 different people at the same time? If you had a static play game method, right, it would be playing one game. And so if you were, you know, making a 20 question server where different people could come in and play 20 questions, each time somebody connects and says, hey, I want to play 20 questions, you'd want to create a new decision tree for them, and play a game using that decision tree. And that works really naturally if you think of the decision tree as being, an instance of a class, and then it pretty naturally says, well, let's put the code for playing the game from that tree inside the class, and let's put the code for updating the tree inside that class, and so on. So it's this kind of higher level notion of encapsulation, right? Taking the data and the code and bundling it, and putting things that go together logically together inside a class. All right, cool. And yes, this is being recorded, as far as I know. All right, cool. What else?
So didn't you say that to usually avoid statics for like bad habits purposes?
In the beginning of the course, I said avoid statics because there was nothing we were doing that would require statics other than public static void main. But they're not evil, they're not mysterious, right? They just can be used to try to do C-style coding in Java. And if one is inclined to try to, not break things into classes and try to do things sort of in the style of C, statics make it very easy to do that. And that makes it very hard to create well-designed classes. And so I suggested people avoid them other than public static void main until we went through them a couple of weeks ago, I think, and discussed what they're actually used for, which is for, making something that you really don't want to be related to a particular instance of a class, right? You want it to be something that belongs to the class itself. And there are definite cases for that, but not for most of what we've done so far. Classic example would be a math function. Well, I don't want to have to construct a math object just so I can say throw away object dot square root. I really just want to say square root, and the square root of a number, I'm passing an argument to it. I don't need a math object, right? I could make a math object called m1, a math object called m2, and when I do m1 dot square root, m2 dot square root, they should do the same thing, right? But with a rectangle, if I say, r1 dot area, or I say r2 dot area, well, those are going to do different things. This is going to give me the area of this rectangle. This will give me the area of that rectangle. So that's definitely not a static method. That's going to be an instance method that depends on, what object I use to access it. So no, don't be afraid of statics, but if you get a message about, calling non-static method from static context, don't just start changing things and adding the keyword static to make the errors go away, right? You should never, ever, ever change your code just to make an error go away. You should only change your code because you believe the change will make your code correct, right? Unless you're experimenting and you want to see what happens. But when you're designing your code and you're trying to write your code, if you get an error, missing curly bracket, don't just go in and add a curly bracket, right? Step back and look at your code and figure out why it's incorrect. Because maybe the missing curly bracket is actually a missing open bracket from somewhere earlier, or an extra open bracket. Or maybe it's a comment that you started with a /* and forgot to close, right? So same thing with statics. If the compiler starts complaining about, this needs to be static, don't just start making things static. Because that's a big sinkhole usually. All right, what else? machines? No.
Please no.
Yeah. Surprise question on the midterm. All right, cool. So let's go back to looking at swing, and let's play around some more with events, and see some more examples of linking events to code. And then let's probably after the break, let's dig into some of this math and arithmetic around responding to mouse events and thinking of how we update the board in response to events and so on and so forth. All right, so this is the Java setup we did last week, and let's make a new project. And let me call this Monday Painter. So when we're doing stuff in Eclipse, especially when we're using Window Builder, you know, we have this thing where you go click, 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 and there's 50 lines of code. I can post that code onto the server for reference, but it's marginally useful at best, because, you know, there'll be 50 lines of code and we'll have written 3 of those ourselves. And it may be the click, click, click that was more important, or the things we did in Eclipse to tell us where those 3 lines of code go and so on. So just looking at the code on the server is not going to be terribly useful.
One of those, it's about the journey thing.
Yeah, exactly. That's a better way to put it. It's about the journey. So I can post the code, and I'm happy to do that, but be prepared if that's the only thing you're looking at to probably, you know, find more confusion than insight there. So with that cheery beginning, let's go ahead and make a J-frame. So we'll go to Window Builder, Swing Designer, J-frame, and let's call this, you know, mainframe. And so there's some code. So I made my font bigger on Thursday because it was getting hard to see. So you can go to Window Preferences, and if you type something like font, so under General Appearance, Colors and Fonts, I did Text Font. Under Basic, and I set it to 14 point. Yeah, so this is you know, make a fresh pot of coffee kind of exercise if you're into that, because, you know, there's you know, the word font pops up in all of these different areas, and eventually you find it, and then you just kind of, like, you know, write down lots of notes and hope that it doesn't change in the next version. But
all the IDEs I ever use have too many dang settings.
Yeah, and they rarely go away, so you end up with, like, you know, 15 different ways to set something, but you don't know which one's going to take precedence.
VS Code does a decent job of, like, allowing you to search and change things, but even still, it's still like,
yeah. And, you know, the worst is indenting, because it should just be the formatter or the typing, but it's, you know, all of these different, yeah. So I mean, you try to edit the formatting rules, and you've got, you know, all of these and all of these, and there's no one box to just say stop, you know, don't do any of this. So, but you know, it's what you've got, and in a job, in another course, you know, you're going to be told, hey, you have to use this version of this IDE, you know, so be ready to do that tomorrow. And so you go home and you spend the night learning the quirks and details of a particular system, and then you go forward from there. So the more you do this, you know, the more practice you get, which is always good. I've been recording, but I just put the notice up there. All right, so we've got a J-frame, and if we go to the design window, we've got our usual interface here, and here's a picture of the J-frame. And let's go back to making our Etch-a-Sketch program, right? So let's follow mouse events and do some stuff. So I'm going to add an event handler, and I'm going to say mouse motion, mouse moved. And
it's like a very heavy event handler.
This one?
Yeah, mouse move.
Yeah.
Seems like that would get. You'd really want to make sure you didn't have that more than once.
Yeah. So listeners, right? So someone asked about what some of this code does, and I don't want to dig it apart. I don't want to take it apart too much right now, but basically, you know, we've got a Jpanel. That's that window inside the main J-frame, and we're calling a method called add mouse motion listener, which is basically writing a piece of code that we can say, hey, run this code when the mouse moves inside this component, this Jpanel, right? And mouse motion adapter is, I believe it's an interface. And you can find JavaDoc on all of this stuff, but mouse motion listener or adapter mainly needs a method called mouse moved. And mouse moved is called with an object that tells us about the mouse motion, and then we can do whatever we want in here. So let's do this. Let's save the XY position of the mouse event. So I'm going to go into my my Jpanel. I'm going to call a method to save my XY position. And so let's tweak this code a little bit. So right now we're saying that content pane is a Jpanel. So here's the J-frame. Here's the panel inside content pane. It's a Jpanel. All right. We're going to change this to be. I'm going to call it a my panel. So we're going to override, we're going to extend the Jpanel class into an object of our own choosing, something called a myPanel, so that we can override the paint method, so that we can tell that paint method, hey, paint a rectangle for us. So I'm going to come down here and I'm going to say, let's make a new class. And I'll call it myPanel. And I think I can come down here and I can actually say that I wanted to extend another class, but I'm just gonna do the usual business, construct a myPanel, and inside the code for that, I'll say it extends a Jpanel. I'll hover over this and say go ahead and import Jpanel from Java Swing. And I'm going to say public void paint graphics G. And here I'm going to say g.fill rectangle. Let's do an oval. Ovals are fun. So we'll fill an oval, and I'll do some XY, and I'll make it a 10 by 10 oval. And I'm being all right. So we'll come back and we'll fix the errors in here because we haven't defined X and Y. But now we have this thing called a myPanel, And so over here in the mainframe, instead of a Jpanel, I'm going to create a MyPanel. And I don't think I need a Jpanel anymore. Alright, so what do I do when I get a mouse event? I want to save the XY coordinates of the mouse event inside the panel. So I'm going to say, so my panel is called Content Pane. So I'm going to call a method we haven't written yet called save mouse location. I'm going to pass it e.getX and e.getY. So that's all kosher, except we haven't written this save mouse location. So let's
did a comma instead of a period there on E, get X.
Oh, thank you. That probably saved us 10 minutes of debugging later. All right, so let's make this. Let the mainframe save the XY coordinates of a mouse event. So this will be public void save mouse loc integer x integer y. Alright, I'm going to do something different here. I'm going to use a new class called point. And point is kind of like a glorified struct. It's a class that just has two fields, x and y. And we use it typically for storing, two-dimensional points, coordinates. So I'm going to make a point called last location, and that's going to tell me where the last mouse event was. I'll go ahead and import that while I'm here. And so when I want to save my mouse location, I'm going to do the following. I'm just going to do that. I could also just say last loc.x equals x, last loc.y equals y, but this feels fancier. Alright, so now when I want to fill my oval, instead of doing xy, I'm going to do last location.x and last location.y.
You're gonna want save mouse loc instead of same.
Yes, thank you. All right, so this is almost ready to work. The one issue if we run this is that I move my mouse around and my circle is still sitting up there on the upper left corner, but if I change the size of my window, my circle suddenly jumps. And if I
to call paint or something,
and we need to make sure that when the mouse moves, we not only save the XY position in this last location point, but we want to make sure that this paint method gets called.
when did that paint method? Does that just get called every time the window saves, or?
It will get called multiple times depending on what happens. So if the window gets resized, it'll call paint. If the window gets partially covered up and then uncovered, it may call paint. If it gets minimized and then unminimized, it may call paint. We don't get to call paint, but we can call repaint. And repaint says, hey, swing, call paint for me. And then at some appropriate time, swing will call paint. So all we need to do here is call repaint. And it should cause paint to be called pretty soon. Not immediately, but sometime in the short-term future. This will cause paint to be called, and when paint is called, it will get the last X and Y coordinates that we saved, use those in the fill oval method. And so this will, I did not mean that. This will do what we were doing last week.
Oh, that's neat.
Yes, we've got a crude Etch-a-Sketch program now.
So, that mouse watcher, is that like a very, I guess I'm not very up to date on how, because in like JavaScript, if I want to watch mouse movements, that'd be something I wouldn't want to do because it would be really heavy. It'd take a lot of resources.
Well, it's not bad in this setup. So when a mouse gets moved, lots of stuff happens. Even if there's no clicking or dragging going on, right? Lots of different parts of a number of systems are notified of that. And if we didn't want to do anything, right, we could just return. Some systems, there's a hierarchy of calls, and depending on what you return from here, the next thing in the hierarchy might get called, or the system might decide, I don't need to notify anybody else. But we really, for me, one of the challenges of working with this kind of stuff was getting comfortable with the idea of how much work I'm having the computer do, right? Because it feels like, I'm calling a whole function here. I'm pushing these things onto the stack. I'm saving my local variables. I'm changing my program counter, flushing my cache, flushing my pipeline, just so that I can say, hey, let's save X and Y. And here I'm creating an entire new object, right, and constructing it with X, Y. And this old object is now, needs to be garbage collected. And that just feels really kind of like, wasteful to me. And that took some getting used to. Even though, I know it's not like throwing a food wrapper on the ground or something. Kind of felt that way to me, and that took some getting used to, because my background in computers was 8-bit CPUs, Intel 8080. 1K of memory was a lot. But this is part of why you download something from the web and it's like a gigabyte on your machine, and it takes 20 seconds to start running. It's because of all of this kind of stuff. But that's where we are, and we've got fast machines, and we'll figure out how to deal with all the power we spend and the heat we generate with these. So yeah, it is a lot of overhead and a lot of heavy lifting, but that's where we are.
Got a question?
Yeah.
I'm still trying to get used to like how the event handler works.
Mm-hmm.
Because what you showed me was like code actually does stuff. But
So yeah.
So how do I know? Like what it's you kind of run back and go over like what this event handler actually do, or how does it actually work by detail?
Yeah, so as much detail as I can go into now, right? A content pane is a Jpanel, or for us it's a my panel, but it's basically a Jpanel. And one of the methods available is called add mouse listener. So if you go to the Jpanel, right, it's an extension of a component which has this method called add mouse listener. And add mouse listener, that's what says, hey, I want to be told when a particular event occurs. So it adds this thing called a mouse listener. to a list. Maybe it's a linked list or some other data structure, but somewhere in the mind of the JVM, there's a list of things that need to be notified when this particular event occurs, in this case when the mouse moves. And things are set up so that when the mouse moves, right, the JVM knows about that. It gets something like an interrupt perhaps, and then it goes through the list of everybody who's been asked to be notified about this event. When you call add mouse listener, what you've said is, hey, I want to be on that list. I want to know when the mouse moves. And so when the JVM's going through that list and it gets to where this content pane was added to the list of people to notify, it said, okay, I'm going to notify content pane. How do I do that? I'm going to call a method called mouse moved. If mouse moved does not exist, right, this will be a problem. But as long as we have a method called mouse moved that takes an argument of type mouse event, anytime the mouse moves, this method gets executed. So this is the chunk of code that runs in response to the mouse event. This is the interrupt driven code. Okay. And then we can do from in here whatever we want. For example, saving the XY locations, repainting the frame, and so on and so forth.
So I'm assuming you can put more than one method inside of the add mouse motion listener.
I could make calls to as many methods as I want. I can set the values of variables. I can construct new classes. I could do anything I want in here.
I think he means other functions other than the mouse move function.
Yeah, because this is just to me that you create some kind of like block of code with content panel.add mouse motion listener. That's new to me, because is that all it representing in some kind of interrupt where if this doesn't happen, it'll run that block of code no matter what?
Yep. This is basically turning on those interrupt bits, and this is what goes at location 8, if we're talking engineering 270, right?
And what about the app override just right before mouse move?
That's a little tag. It really has no effect. I can take that out and it's fine, but it's saying, hey, this is a method that's already defined in this class, and I'm making my own version of it. And it's a tag. It starts with an @ sign. It doesn't actually change anything about the behavior of the Java code, but it's like meta information basically. And so a mouse listener is an interface, which means it's kind of a blueprint for a set of methods that we're going to write, including mouse clicked, mouse entered, mouse exited, mouse pressed, mouse released. And we need to talk about inner classes at some point, but it's not the most critical piece at this point. But we'll talk about what's going on here. But basically, this is a method called add mouse motion listener. It's a method inside the content pane, and the argument to that method is all of this. Right? So I'm calling a method with an argument which is actually the construction of a mouse motion adapter, and inside that constructor I'm defining a method that handles mouse motion. And so that's this thing called an inner class that we'll take apart later. But to get on the air with PA4, we don't need to know any of that, right? All we need to know is, hey, I want to do something when the mouse moves. Add the event handler, and it'll take you down to that method that gets called when the mouse moves. And so we can pull whatever code we want in here, and if we want to know what that argument is to it, we can say, let's see what a mouse event is. Well, it's a thing that has these fields and these methods we can call, and for us we're just calling getX and getY. Could have called getPoint and gotten the point directly.
So wait, a point is a type, is a data type?
A point is a class, and it's a class containing a pair of integers x, y, and then some methods.
So if I were to call points, I would just get 2 values.
So you can construct point with a pair of values, or with a point, or with nothing, which makes the point 0, 0. I could change the xy values by saying, you know, the name of the point dot move and give it a new xy. And so we're thinking of this as, you know, a pixel on a display. When we say, you know, last location dot move, nothing's actually moving. We're just updating these two fields, x and y, inside this object. But if we think of it as, you know, we're moving this pixel from this point to that point, then this move method kind of makes sense. Or if we think of it as, hey, I want to move this point, you know, 1 unit in x and 2 units in y, we could say, you know, name of the point dot translate 1, 2. But it's really just changing xy to be x plus dx, y plus dy. And I mean, you could write this yourself. It would be, you know, a handful of lines of Java code. But it's convenient sometimes. And it's convenient here because what I'm going to do is I'm going to take these points that we're getting from the mouse listener, and instead of just saving them in one variable, I'm going to save a queue of these. Because right now when I run this, it's drawing 1 point at a time, but I'm doing something I shouldn't be doing, right? In particular, if I change the size of the window, all my previous points disappear. And so I'm doing something wrong in here. What I really should be doing, well, let me show you the problem like this. So I've got my frame, I've got my panel inside here, but I can't really see it, right? So I could set a border on this. For example, I could give this a beveled border. Well, maybe I can give it a beveled border. Oh, I should have done something different. Alright, I'm not going to try to motivate it. Let me just tell you. The paint method, right, normally does a bunch of things. One of the things the paint method does is it clears the component, sets it all to a background color. It'll also draw a border if you have a border around it, and so on and so forth. We're taking over responsibility for the paint method when we do this. We're saying, hey, I'm going to tell you what to do when you call the paint method. And we're only telling it one thing. We're saying fill in an oval. But really, the paint method should do other things, including setting the whole component to the background color, drawing a border if there should be a border, drawing other ornamentation if there should be other ornamentation, and so on. We don't want to write all that code in here. We just want to write the code which says fill the oval. But we still want the default behavior of paint to take place. So we're going to punt here. We're going to, in the beginning of our paint method, we're going to call the superclass's paint method. And by doing that, we're going to get the proper but less exciting behavior, which is we have a circle that follows our pointer around. And that's really what this code is saying, right? It's saying in the paint method we should just draw an oval where the XY position is. Well, that's exactly what's happening right now. But we lost the kind of fun Etch-a-Sketch behavior of seeing, you know, a whole trail of points.
I forget. Can you kind of remind me of what a super.paint does?
It calls the paint method, since my panel extends Jpanel, super.paint says, hey, call the paint method from the Jpanel version of whatever this object is. In other words, call the original paint method, not the one that we just overrode right here, right? If we just say paint, it does this. But if we say super.paint, it does whatever the original paint method did.
And the original paint method just kind of, does it just like create a just paint something, but then it kind of overrides it, where it doesn't record the last. It just keeps repainting instead of it just paints. It replaces the oval basically.
Yeah. So the original paint method erases the component, right? Sets it to the background color. If we put a border around the outside, it'll draw a border around it. It does everything in preparation for displaying the component, basically. And if we don't do anything else, we just get, you know, an empty background. But if we also do something like, you know, say fill oval, then we get an oval appearing on top of the component. So let me just try this. I don't know if this will work or not. Let me just pop a label in here. Or let me pop a button in here. Right. So I've dropped a button onto my panel, but I don't necessarily see that button. Right. My button just disappeared. And if I do this, all of a sudden my button reappears, right? This is not working the way that it's supposed to be working. Well, why is that? It's because I've taken over responsibility for painting the panel. And my paint method... Oh, I closed it. My paint method... Yeah, I'm really breaking.
One of its responsibilities is making the button.
One of its responsibilities is making the button appear. And I've circumvented that. I've said, hey, I'm going to write the paint method, and I said fill an oval, but that's all I said. Yeah, I'm breaking. Oh, I'm popping up over here for some reason. Right. So if I put this back in. Now I'm saying, hey, do whatever, you know, the default paint method does, and then go ahead and fill the oval. So now the default paint method draws this button, and it keeps it very well behaved, right? So we almost always want to call this the superclasses paint method in the beginning of our paint method. All right, so that gives us a nice, you know, controlled behavior, but it breaks our nice little trail of dots that we had. So if we want that trail to be in there, we just make a queue of points. So what I'm going to do is, in my Jpanel, instead of just making last location a single point, let's make a linked list of points. And let's import linked list. And when I want to save my new XY coordinates, let's just add I'm just going to rewrite it because it's messing with me. Let's just do last location, which is now a linked list. Let's call its add method, and let's feed it a new point. Constructed with XY.
So with the new point, new point returning an integer, or right? Because
New point returns a point.
but you're putting a point inside of an add method. Does the add method only take integers?
It's a linked list of points, and so the add method expects a point. Yeah, so we're using generics.
Oh, I don't know why I was thinking integers for some reason.
Well, usually our linked lists are integers. But since it's a generic class, we can make a linked list of points just as easily, right? By just specifying the point inside here. And now the add method expects a point, the remove method will remove a point, and so on and so forth. Alright, so now when we say save the mouse location, it's going to make a new point out of that XY pair, and it's going to add that to the end of the linked list. And so now, after I clear the component, let's draw all of the points in the linked list. So let's go I equals 0, I less than last location dot size. And let's do last loc dot get I. So this will return a point, and we can say dot x to get the x field, and then last location dot get parentheses I dot y. So think about what's happening here. Last loc is a linked list of points. It has a get method. If I say get I, it gets the ith element from that linked list. And then that element that it gets is a point, and points have an x field, so this gets the x component of that point, and so this will fill an oval at that xy location from the linked list. And so now if I run this, I should be back to my nice trail.
And it should stay if you resize.
And it should stay if I resize.
Beautiful. Draw the Mona Lisa.
I just did. It's from a different perspective. All right, cool.
LSDs.
Yeah. Maybe it's a super up close of like one eye. All right, so that's you know, there's a lot going on here, right? There's not a lot of lines of code here, but this, right, is really the only thing we wrote, right? Was this statement right here and a call to repaint, right? But this, because it's inside this listener, right? We're going to call the getX, getY methods on this object, this mouse event object. Get the XY pair, pass that to save mouse loc. Save mouse loc is going to make a point out of it, add it to the end of a linked list, and then our paint method, which runs after we call repaint, is going to iterate through all the elements in the list, get each point, find its XY position, pass that as an argument to fill oval, and then make that appear. This will eventually use up all the memory on my machine if I run it forever, because it keeps adding points to a linked list. So let's limit the size of our linked list to, I don't know, 25 points. So in the beginning here, right, after I add a point, let's make sure our list is not bigger than 25. So let's do this. If our list has a size bigger than 25, let's remove the first element from the list. And so add adds to the end of a list, and this is going to remove from the beginning of the list. So this is a queue, right? This was like the queue implementation we did using a linked list in days past. And so this little bit of code here is going to say, hey, every time you add something to the list, if the list is bigger than 25 points, get rid of those older points. And so if I run this, I've got an Etch-a-Sketch, but you know, with only a fixed number of points. All right, and then just one more tweak we can make on this. Let's make this button do something. My
Make it
button.
clear them all.
Yeah, my button is still not showing up. That's okay. I'm going to add an event handler. I'm going to say action performed. So I'm going to come in here when my button gets clicked. And what should we do? Well, I'd like to clear that linked list. But the linked list is not declared inside the mainframe. It's declared inside the panel. And here's a design decision, right? I could come into the panel, which is called content pane, and I could access this thing called last location, and I could, you know, do something to erase everything in it. But I'm not going to do that. I'm going to call a method inside the content pane. I'm going to call it doClear. And that's going to clear the linked list of points.
Nuclear is lesser known younger brother.
That's right. So why am I doing it like this? I'm trying to encapsulate, right? The linked list of points is very clearly inside this class. Why? Because we need to get to it to do our painting. And so I'm got the method for saving it inside this class. Well, I'm going to put the method for clearing it inside this class also. So let's put that right in here. So let's put a method to clear all the points from the canvas. And I know I could iterate and I could delete all of the elements one by one, but there's a clear method. How about that? So this is super duper easy to do. It's one line. I think I have to call it clear. All right, so let's run that. And we've got our lines drawn. And if I hit the clear button, it makes them go away, but not until I move the mouse. So,
you need to call repaint.
Because I need to call repaint, right? All I'm doing when I respond to that mouse motion is I'm updating memory, right? But updating memory doesn't change what we see.
Is repaint a method?
Repaint is a method inside the content pane.
Okay.
Which says, hey, call paint when you can. So when we saved a new XY location, we called repaint. When we clear out that queue, we're going to call repaint.
So a good idea would be to not redeclare repaint, maybe?
Yeah, and don't call repaint inside paint. Because that'll blow your stack. Well, your computer stack. Alright, so now if I hit that, clears the screen. All right, this is entirely typical of the kinds of things you're going to be doing for PA4, right? And it's one of these things where, you know, again, if you start writing, you know, thousands of lines of code, step back, take a breath, right? And think about your problem from a different perspective, because you may be doing too much work, right? To clear that queue took one line of Java, right? I didn't have to go through and find each pixel and overwrite it with a gray pixel so it would become invisible or anything like that, right? If I simply clear the linked list and I say, hey, go ahead and call the paint method, the paint method will clear the entire display. That's what the superclass's paint does. And then, since the size is 0, it will not call fill oval at all, and my display is blank. The button is still there because the button got drawn by the superclass's paint method, right? So this should feel like, you know, the executive sitting in the big armchair with the plush carpet, right? And you just kind of like, you know, do this, do that, take care of this, right? You're no longer down in the trenches doing the nitty-gritty work, right? You're up at the much higher level, and all of the stuff that's in these classes, that's what's doing sort of the low-level detailed work, right? And when you are doing very detailed low-level work, it's for something, you know, very particular to your task, like, hey, let's figure out what the two corners are of the box that the person just clicked by, and let's see if there's a line there, and if there isn't, let's make a line, and let's, you know, do this and that and so on. So this is letting you concentrate your time and energy and focus, you know, on the parts of the program that are, you know, unique to this particular program. And that's really where you want to be, right? If you're trying to make a game, you want to be concentrating on making the game, not implementing a linked list or things like that. So this you know, deferring to other classes is something that's going to come up again and again. All right, let's do a short break. Let's come back at 5 minutes, and then we'll go through some of the details of setting up these coordinates to respond to mouse clicks and such. back. I guess I closed Canvas. Let me try opening it again. I'm looking for a resource up here. All right. Let's see. So if you refresh Canvas, I just published a little document on there.
The sight of Canvas has started to induce a stress reaction in me. It's kind of bad.
That is bad. There are worse things, but that's pretty bad. I've had students where the thought of code induces a stress reaction, and that's not good.
Problem isn't code. This class is easy.
Cool.
Well, I would say it depends on the person.
I would say it definitely depends on the person and the experience and other things, but that's cool.
Well, this class it's fun. It's, you know what I mean.
Yeah, cool.
It's fun, but challenging because I'll be like left confused and doing a programming assignment and be thinking like, how do I actually do this? And then I have to come by office hours and so on.
Yeah.
So.
Those early office hours.
Mhm. Especially when I see like a lot of people in like queue to get in, and I feel kind of bad for spending a lot of time trying to solve the problem when other people got problems too.
Yeah, but there's plenty of office hours. It can get tangled up sometimes right before an assignment, but across a week with 5 hours, I spend a lot of that time just kind of like grading and stuff like that, waiting for students to come in. So yeah, sometimes when you come in, you might see a lot of people waiting, but there's other times when there's not. So usually, if somebody needs to get in, we can find a time for that. So yeah, don't ever feel bad about coming by office hours and making use of that, because that's really, I mean, I try to make my lectures meaningful, and I try to say mostly good stuff that's going to be helpful to you, but nothing compares to what I can do actually working with someone and looking at their particular code and asking them questions and things like that. So I mean, that's my preferred. I would love this whole class to be just a bunch of one-on-one, but that would take like 40 of me to do that. All right, so let's talk about coordinate mapping. So I just published this on Canvas. So under resources, there's a thing called coordinate mapping. It's a little one-page PDF, and you may find this useful for PA4 and for life in general. So there's a bunch of stuff on here, but the basic setup is suppose you have some region, for example, a grid of dots on which you're going to play a game. So some things to keep in mind. So I should have written it on here, but x goes from 0 increasing to the right, y goes from 0 increasing going down. So we talk a lot about rows and columns, and if you can keep track of rows and columns, your life will be infinitely better, right? This was something that I needed to just memorize at one point, but once it was ingrained, it became a wonderful world. So row is row 0, row 1, row 2, row 3. Rows go across. Columns go up and down. I think of like Greek columns outside a building. They go up and down. That's how I remember that. So to count a column, we go across. This is column 0, column 1, column 2, and so on. And then rows are just the other ones, but you know, first row, second row, we're kind of used to that terminology also. All right. So when you draw a position inside brackets, usually when we say, you know, something comma something, the first number is the row, the second number is the column. That can change in different contexts, but for most of what we do for C, for Java, the first number is the row, the second number is the column. So when I think about, you know, element 3 comma 2, I'm talking about go from row 0, 1 to row 3, and then column 0, 1, 2. So down 3 over 2, that gets me to cell 3, 2. Cell 1, 3, I go down 1 and I go over 3. So keeping that straight will help you infinitely. All right, so with those pinned down, we can start to do some association between cells and XY coordinates. And you know, in our playing field, if it's 8 by 8 and each box is 50, this is basically X goes from 0 to technically 399. And Y goes from 0 down to 399. And so our question is, you know, if you click somewhere here, where are you in the board? Well, the first question is probably, what box are you in? If we think of this as a grid of boxes, what row and column does this click correspond to? Now if I click here, you know, I'm pretty sure I'm in row 0, column 0. And if I click down here, I'm pretty sure I'm in row 7, column 7. But what about this point right here? I don't know. So let's look at XY. Yeah, go ahead.
How are we going to handle, because two boxes next to each other will share one side, right?
Mm-hmm.
How are we going to handle that? That seems really interesting.
So it's just an extra action that you have to take. Let me see if I have this up. So on the there's something bold-faced in here that talks about. All right, so mouse clicks. After deciding which side of the box was selected by the user, the program checks to see if that line has already been drawn. If it has, report that as an error and ignore. Otherwise, set the appropriate Boolean in the box. Then also update the Boolean in the appropriate adjacent box. So if we click right here, we're going to figure out, okay, we're in this box. We're in row 3, column 1. And we were at the top of the box. We're going to set 3-1's top Boolean to be true. Well, since that's row 3, we're going to subtract 1 from the row. We're going to go to row 2, comma 1. And since we set the top of 3-1, we'll set the bottom of 2-1. If we set the left of 3-1, we would set the right of 3-0. If we set the right of 3-1, we'll set the left of 3-2. And if we click the bottom of 2-1, we'll click the top of 3-1. So it's a few if statements to basically say, hey, you know, which box is adjacent, and some extra if statements. If we click the top of box 0, 1, we don't want to try to set the bottom of box -1, comma 1, because that'll give us an error. So if we're in row 0 and we click the top, we don't have to do an adjacent box. If we're in column 0 and we click the left, we don't have to do an adjacent box. If you're in the last row and you click the bottom, or the last column and you click the right, we don't have to do this. Otherwise, you have to move over one box by adding or subtracting 1 from the row or the column, and then set the opposite side, top to bottom, bottom to top, and so on. So that is an interesting part of code. It takes some thinking about the different cases, and it's not hard. It's just lots of if statements, and if you get one of them wrong, it'll drive you nuts for a while, because it'll be like a weird quirk that only shows up sometimes. So be very careful if you decide to write that using a lot of copy and All right. So let's imagine some coordinate here. Let's suppose that this is 231 and 111. All right. So our first question is, what box is this in? Which is really a question of what is the row and the column of this point? Where does it sit in this 8x8 grid? Well, each box is 50 by 50. So if we drew an expanded picture of this, it would look something like this. So our point would be something like right here, 231, 111. All right, how do I know that's where it goes? So if this is x equals 0, this is 50, 100, 150, 200, 250, 300, 350, and 400. And the same thing in y.
I don't know why I'm thinking of like modular operators, even though that's incorrect.
That's part of it. So it's going to be doing modulos and it's going to be doing integer division. So the integer division part will tell us, for example, what column are we in. So everything from 0 to 49 is going to be in column 0. Everything from 50 to 99 is going to be in column 1. So if we take x divided by 50, and we just take that as an integer, that's going to be our column. So 231 divided by 50 is 4 point something. Our column is going to be 4. 0, 1, 2, 3, column 4. And if we take y and we divide it by 50, that's going to be the row. 111 divided by 50 is 2 point something. The row is equal to 2. 0, 1, 2. So this is row 2, column 4. Go ahead.
So, I guess when you're running down, I'm assuming that's like the floor. Like you do like math.floor, which just gives you like the basically like it kind of removes decimals basically.
Yeah, but if you just do integers everywhere, that happens automatically. And since our mouse listener will automatically give us integer xy coordinates, if you just take that and divide it by 50, and 50 is an integer, you'll end up with an integer, and it'll be floored. So that's noted on the bottom of this coordinate sheet. Finding the row and column from xy. If you have coordinates xy, it's inside cell RC, where R is the integer of y divided by the cell height, and C is the integer of x divided by the cell width. And in this case, the height and the width are both 50, but more generally, right, it's y over height and x over width.
Then how do you find what side it is?
How do you find what side it is? So this is where modulos can come in, right? If you know a particular point, well, if you know the coordinates of each corner of the box, we could find how far we are from each side. Now, a really slick way to do that is to use moduli. If we take this x-coordinate mod 50, we're going to get 31. It means we're 31 in on the x direction. And if we take the y-coordinate 111 mod 50, we'd get 111. It means we're 11. We'd get 11, which means we're 11 down in the y-coordinate. But we can also do this a little more, a little less slickly, right? So once we know that we're in a cell like 2, 4, we can find the coordinates of the 4 corners. And the coordinate of the upper left corner is just the column times the cell width, the row times the cell height. The upper right corner has the same y coordinate, but the x coordinate increases by the cell width. The lower left, y increases by the height, and the lower right, the x and y both increase by the width and the height. So we start with the upper left corner. It's the row and column times the height and width. And so for this box 2, 4, so we clicked on this point at 231, 111. And we said row equals 2, column equals 4. So we can use this. X is going to be the column times the cell width. Cell width is 50. So X is going to be 200. And Y is going to be the row times the cell height. Cell height is 50, so Y is going to be 100. So there's the coordinates for the upper left. And then if we add 50 to X, this will give us 250, 100 for the upper right corner. And then the lower left will be 200, 150. And then this corner will add 50 to both, so this will be 250, 150. So this is all arithmetic, right? This is just using these calculations. And so now we know two sets of information. We know the coordinates where the mouse click occurred. And we also know the coordinates for each corner of the box. So let me draw this a little more realistically. So I think the point would probably look like it's over here. Actually, it'll probably look like it's up here. All right, so how do we find an edge?
Hey, can I have a question?
Yeah.
How would you know if you get how do you find the four dimensions using the mathematics?
These?
Like the four edges, yeah, the four edges, yeah.
Ah, so these formulas here. So the upper left is column times width, row times cell height. And then this point is whatever that X is plus the cell width, and it's the same Y. And this is the same X as here, but the Y gets increased by cell height. And this is this XY with each of those increased by cell width and cell height. So find the upper left first. Just multiply the column by 50 and the row by 50. And then add 50 to X over here and add 50 to Y down here.
So what would happen if you resize the window?
So for PA3, the box sizes are fixed.
Well, PA4 you mean?
For PA4, yeah, the box sizes are fixed. They're always 50 by 50. But if you wanted to make this resizable, right, instead of hardwiring 50, you would use cell width and cell height. And maybe you would take, the entire width of your panel and divide it by 8 to find what cell width is. And take the entire height divided by 8 to find what cell height is. And then you would just use those in your calculations, and these would be whatever they came out to be. And you're welcome to do that if you like. It's not required. But if you want to make the whole game resizable by changing the size of the window, that's a nice feature.
I might start with this hardwired before.
Yeah. Start with it hardwired, but don't just say column times 50, row times 50. Just make yourself in the very beginning some integers called cell width and cell height, and do column times cell width, row times cell height. And then later on, if you wanted to make it resizable, all you've got to do is change these things, and everything else works automatically. All right, so we've got the coordinates of each corner, and we know the coordinates of the point we're interested in. The next order of business is figure out your straight line distance to each of the four edges. So what's the shortest distance from this point to the top edge? What's the shortest distance from this point to the bottom edge? And so on. Well, this is just the y-coordinate of the point minus the y-coordinate of this top line. Right? Everything on this top edge has a y-coordinate of 100. So take the y-coordinate of your point, subtract the y-coordinate of the top. That gives you a distance of 11. And then take the y-coordinate of the bottom and subtract the y-coordinate of this point. That gives you a value of 39. And then for x, take the x-coordinate of this point, 231, subtract the x-coordinate of the left line, that's 200. This gives you a distance of 31. And then for the right, take the x-coordinate of the right edge, that's 250. Subtract the x-coordinate of the point, 231. That gives you a 19. All right, now I know the direct line distance from my point to each of the 4 edges. Find the smallest one. So I've got distances of 31, 39, 11, and 19. 11 is the smallest. That tells me, hey, the person clicked closest to this edge. And now you're all set. So, general word of advice here. Don't try to get too fancy with this, at least at first. If you want to get fancy later, that's great. But to begin with, right, everything that we just did, you can do that. You can do one line of code for each one of those steps. You can probably imagine ways to combine steps. You can probably imagine ways to do this that will be slicker. My suggestion is don't do that, right? Unless you're very confident about this and you just want to have fun and play with it, then it's great, right? Go to town. But if your concern up front is, you know, I really want to get this to work, I really want to be able to turn this in and get 100% on it, right? Don't start off trying to get fancy, right? How do I find the x-coordinate of the top of the box? I'm going to store it in a variable, you know. I'm going to do a set of calculations. I'm going to say, you know, upper left corner x equals this. Upper left corner y equals this. Upper right corner x equals this. I'm going to make another variable, upper right corner y equals this. Even though it's the same as upper left corner y, I'm not going to try to remember that. I'm going to make 8 variables, upper left corner xy, upper right corner xy, etc., right? It's variables, but you know, this is like painting, you know. Come up with a naming convention, embrace your camel case, you know, and make it look the way that you'd like it to look. And who cares if you've got 8 variables when you only need, you know, 7 or 6 or 4, right? Don't make yourself have to keep thinking while you're doing all of this business, oh, this is actually, you know, upper left x, right? Make yourself a variable called lower left x, lower left y. And now when I'm trying to find, you know, what the y coordinate of this line is, I can just say, oh, that's, you know, lower left y or lower right y, right? Or maybe, you know, I'll make 4 more variables. Left x, right x, top y, bottom y. Right? It's your code, and this helps document it, and it helps, you know, keep you straight with what you're doing. And if it doesn't work and you have to debug it, right? You're not trying to debug a statement which says, you know, 4 times this plus 50 times that minus this other thing, blah blah blah, right? It's just, you know, distance to bottom equals y bottom minus y, you know. Yeah, go ahead. You had a question? A comment?
Yeah, well, mostly a question or comment.
Mm-hmm.
So if I was going to create could I make an entire, like, 2D array of integers, or what would be the best idea for storing, like, the coordinates of the cells?
I'm not sure I would want to store them. You could make a 2D array of integers, but you know, for each box, you want to record XY for upper left, upper right, lower left, lower right. Again, you know, if I need the lower left of this cell, I could just say, well, that's just upper left of the cell that's 1 column below it. Don't go down that path, not up front, right? And so if I were to store these in arrays, I would need, an array for upper left x, an array for upper left y. I would have 8 arrays, another 4 arrays to store the x, y for the edges. And there I feel like I'm going to be getting tangled up because I have to initialize all of those. And how do I initialize them? By doing calculations like this. So I would just go ahead and in the beginning of your mouse click code, do those calculations once up front for the particular x, y, figure out your row and column, and then figure out the coordinates for the corners, and then maybe figure out the x coordinate here and here and the y coordinate there and there. And then calculate these 4 distances. So x minus top x, bottom x minus x, y minus left y, and right y minus y. Or you can use absolute values if you want, and you can subtract in any order. And then how do you find which one is closest? If x distance is less than, if top distance is less than bottom distance, and top is less than left distance, and top is less than right distance, then do your code for clicking on the top. Else, if bottom distance is less than top, and bottom distance is less than right, and bottom distance is less than left, then do your code for the bottom. It's a lot of code, but it's not a lot of thought, right? It's a good exercise in copy and paste if you're careful with changing the right things. You could make a method, that you give it these 4 numbers and it tells you, which one of those is which edge you're closest to. You can spin this however you like, but it starts with understanding kind of these coordinate mapping mechanics. This also lets you deal with that situation where someone clicks right in the middle, right? Maybe 11 and 19 are too close for my taste. Maybe I want to make sure that your closest distance is at least 10 less than any other distance. And so if I clicked, at a point where I was 18 from the top and 19 from the edge, maybe I'm going to say, that's not a valid click. I'm going to ignore it. And the person's going to have to move their mouse up and click close enough to the top that my code says, oh, okay, they meant the top edge. And that's one way to deal with, what if the person clicks right in the middle, for example.
Can I comment?
Mm-hmm.
So if I think you'll message in chat.
Yeah.
If the person clicks right straight in the middle, if they're that precise. But if it's somehow like the left and the right are equal to each other, personally, I would just have to put that message in. It's not a valid click or something like that.
So you can make it your choice. So you could just let it do whatever it does. In which case, if my if statement said if this distance is smaller than that distance, right? Else, use this distance, right? Then maybe it would take this edge. Or if I said if this distance is less than or equal to the other distances, maybe it would take this one. Or maybe I have inequalities and none of those if conditions will fire and it will basically ignore the click. So I wouldn't bother the user. I wouldn't put up, a modal dialog box saying, you clicked in the middle and make the person hit the OK button. You don't want to, disturb the user like that. But, if they don't click somewhere appropriate or somewhere that you understand, you can just ignore it. And nothing will get darkened on the screen, and they'll go and they'll move their mouse and click it somewhere else instead.
Okay.
And these are in the category of the fun stuff you get to experiment with. Once you've got the basic setup going, then you can start to imagine how you'd like to tailor this. I've seen students who will use mouse motion so that when you get close to a line, maybe it'll make that line flash so you know which line you're selecting, or whatever. But that's the basic mechanism for finding out which edge you clicked next to, and it's very unelegant, right? It's really just kind of like a bunch of conditional checks, but there's nothing wrong with that, right? Your game in the end is going to be elegant and beautiful. The way it's implemented doesn't have to be. It's, you know, sausage. It can be whatever it takes to make it work.
Question.
Yeah.
How would you check if there's already a line occupied in the box?
Well, your boxes, the main memory you're going to have is an array of boxes, if you follow my suggestions. So the box class had a Boolean for top, bottom, left, right, and the whole board was basically an 8x8 array of boxes. So if I decide I'm in cell, whatever cell we ended up in, 2, 4, and I clicked right here and it found I was closest to the top of this. Next thing I'm going to do is I'm going to say, you know, box equals board, bracket 2, bracket 4. These aren't hardwired, right? They come from doing this calculation. And then if box dot top that's an illegal move because the top field has already been set true. So they're trying to click on a line that already exists. So what do? I mean, maybe you just ignore it, or maybe you put a message in the title bar of the window saying, you know, that line is already taken, or something like that. And it's not a bad approach when you're doing this kind of stuff. I think it's not a bad approach to take advantage of this title bar, right? So we can call a set title method in the JFrame, and you can put information up here. If you just want kind of a one-liner message, you could put something there so that, you know, if they try to make an illegal move, you can say, you know, line already in use, try again, or something like that. Alright, and if this is not set, right, then you go ahead and you set this, and then you say, okay, well that was in row 2, and so there's a row above me, and so now I'm going to say board bracket 1 bracket 4 dot bottom equals true. Well, what else now? I have to check to see if this box is now completed, and I have to check to see if this box is completed. And if either of those is completed, I need to put an initial in there to say it's owned by this person. I need to update the scores, and I need that person to go again. Well, that's all stuff that's really great to throw into a separate piece of code.
A comment.
Yeah.
To check if all is true, can we just use like what we did in like CSE223A, where we basically do an AND statement for all the booleans?
Yeah, so you can say inside, so you could make a method called, you know, box completed inside the box class, and it can just return top, double ampersand bottom, double ampersand left, double ampersand right. And that'll return a Boolean that tells you if the box has been completed. And that's nicely modularized now, right? Because now I can just call the completed method in the box and I'll get a true or false. And so you can make yourself a method like, you know, update boxes that goes through your array of boxes and looks for each box to see if it's completed. And if it is, and the character associated with that box is blank, you know that box was just claimed just now. And so you've got a new box. And so you could have that update board method return a Boolean saying, hey, did any boxes get completed? And maybe as an argument to that method, you pass the initial of the current player. So now after you do this business of updating top and bottom, I just say, you know, if updated board parentheses current player, you know, it's still the same player's turn. Otherwise, switch the player. And that update board would just go through each element in there and pull out the box and check the Booleans. And if they're true and the character is blank, set the character to the initial and mark a flag saying when I'm done with this, I'm going to return true to show that I updated at least one box as being owned now. So those are ways in which you can sort of think of fancifying this, right? Is in the modularization, in the deferring of behaviors into you know, other methods that basically look at the memory and update information based on that. And so this is this idea of data-driven development, right? I update the data in terms of these booleans on each box object, and then I use code that looks at that data and decides, hey, did the person just complete a box? Hey, who owns this box? Hey, whose turn is it, right? What score is it? All of that stuff can be derived from the data in this array of boxes. So lots of different directions to go in and think about how you want to implement different behaviors. And that, I think, is the funner part of programming, right? That's the real creative aspect. That's the part where you can sort of take your own approach to things, your own view of things, and turn that into your program design. So hopefully you have fun with that. All right, so that's on Canvas. If it's useful, great. If it's confusing, don't worry about it. Just ignore it. But that's just some coordinate arithmetic. And when I was writing this up, I was thinking about it and realizing that it probably took me a few weeks when I was first doing this kind of thing to really sort of like conceptualize what's going on here. And sometimes, you know, you put together a document like this, and it can give the false impression that this is supposed to be obvious, or it's supposed to be easy to understand, right? This might take you a while to sort of come to terms with, or you might, you know, come to terms with it some other way and completely ignore this, or maybe this will help you figure out a different way to think about it. But if it's useful, you know, it's there for you to use. But I don't mean to say that this should make perfect sense right now. So ask questions or do some experiments and so on and so forth. And this kind of thing will serve you well, right? Anytime you're doing app development or games or anything like that, you're going to be doing this kind of mapping between coordinate space, right, x, y's, and some other space. In this case, you know, a space of boxes. And that's just a classic graphics issue. All right, anything else for now?
So, sure, thank you. You can go. Oh, okay, never mind.
Yeah, go ahead.
Just kind of, I thought I have an idea. So, could I create like just like the did for PA3, could I create like a small class of defining what a box is,
Mm-hmm.
and then have it, and each of the boxes represents like, it's basically a cell.
Mm-hmm.
It'll probably have, it might have like 5 or 6 booleans inside of it, because of like, you know, checking if left, right, up and down true, or checking if the box is already occupied, and so forth. I'm trying to think of like, what would be a good design choice for defining a box or something like that.
So I recommend a box class that has, you know, 4 booleans, like you said, top, bottom, left, right, or whatever you want to call them. Probably put in there something to hold a character of who owns the box, since our whole board is going to be an array of boxes. So if I complete a box and I put an N in there, right, I want something in that box object to say, hey, this box was claimed by N, or player 1, or something, right, to differentiate. And that's probably it for fields that you need, but you can start adding more things. You could put a field in there for completed, or you could just make a method called completed, which returns, you know, a boolean if all 4 edges are true, which I think is a better way to do it, rather than introducing a new variable. And then some of this business of, you know, finding coordinates for corners, you could make that part of the box class if you want. So that if you have a box object, you could say, you know, box dot upper left x, and there would be a piece of code that would return the x coordinate of the upper left. Or you could switch to points, right? You could have a method that returns a point, and the point is, you know, the coordinates for the upper left, the upper right, and so on. And it's kind of up to you. How do we find which edge you click closest to? Well, we need to you know, take the x coordinate of the top, subtract that from the x coordinate of this point. Now, how do you want to do that? Do you want to do these calculations like
Probably
this
simple.
to figure out the x coordinates of the top, or do you want to call a method to find that, or what?
I meant to create simple if statements to compare y's and x's, and then do accordingly depending on what situation I get.
Mm-hmm.
It's gonna kind of depend though.
Yeah, yeah.
So I was mentioning to you earlier about how we're going to create like an entire list of boxes instead of a variable, so I'll know like which box to click, kind of idea. So what would your idea be for creating an entire list of boxes with the associated x and y coordinate?
So just make an array. So box, board, right? But let's make it a two-dimensional array. So let's do box, board, bracket, bracket equals new box, 8, 8. And now I can say, you know, board, bracket, row, bracket, column, and I can get to that individual box like this.
Okay.
And then inside that box, I have top, bottom, left, right, initial, methods for upper, left, or whatever else I decide to put in there.
Okay. I'll try it out. I think I'm trying to work on it with somebody tomorrow, but
Cool.
yeah, that should get us started for at least trying to create an entire interface for it.
Awesome.
All right, thank you.
All right, cool. Any other questions? All right, cool. Have a good one. I'll see you in office tomorrow, or I'll see you Wednesday. Don't forget your midterm Wednesday, 10 o'clock. All right, see you next time.